Okay, I think that we can start. Today, as you know, we are going to talk about detectable plastics for safety application. And the most important sector correlated to this kind of plastics, to this kind of material, is the food industry. So we mainly talk about the food industry, where the safety is for sure very, very important, correlated to the presence of contamination, for example. My name is Jacopo Carabelli, and I work in LATI as a technical assistant, mainly for Italian customers, but also for European customers. Welcome to this new LATI technical webinar. This is the second one of a first cycle of 3 summer webinars. In the first one, you have already learned the material suitable for friction applications, so self-lubricant materials. Today, we are going to talk about detectable materials, while in the next webinar, the 13th of July, we'll talk about the 3D printing and special compounds that LATI has developed for this kind of application. In autumn, there will be other 5 webinars, and the topic will be revealed in the next few weeks. The aim of this technical webinar is not to explain in a difficult way, thanks to mathematical equations or difficult laws, the physics behind the topic, but try to explain to everybody also some complex concept. If you have any questions, you can write them down on the chat, and at the end of the webinar, I'll try to answer. As I already told you, the main topic correlated to detectable materials for safety application is the food industry. For this reason, we'll start to talk about the contaminations, the main problem in the food industry for safety reason. We'll see what is the cause of this contamination and also the effects. Then we'll try to talk about existing certification and standards that are made in order to optimize the food industry safety, and we'll see what kind of detector exists to try to avoid contaminations in the food. At the end of the presentation, the heart of the presentation, we'll see what does LATI propose in order to help the detection of possible contamination that comes from plastic materials. And we'll also see some successful application that we developed with our customers. Okay, I think that we can start from this slide. This picture is taken from Google. There are some newspaper titles where you can read about a lot of foods batches that have been recalled by the supplier because contamination was found in it. As you can see, there are also important companies, and the kind of contamination in this kind of newspaper titles is mainly plastics, but we'll see that is not only plastic that is possible to find as contamination in the food. But it's possible to answer this question: how widespread and what is the nature of contamination? Yes, it's possible thanks to this European organization called Rapid Alert System for Food and Feed. This kind of organization every year makes a report about the number of foreign bodies that are being found inside the foods as contamination. As you can see on the graph, the trend is increasing year after year, but there are no so big numbers. We can think also in another way. We can think also that this trend is increasing year by year, also because also the control are increasing year by year. This kind of warnings can come from mainly two sources. The first one can be correlated to consume simulations. The second one sources is the consumers. If you find some contamination inside the food, please make a warning on this organization or other ones that are working in this kind of safety application topic. But let's have a look on the most important contamination that is possible to find in the food, the most widespread. At the first place, we find metals, but then we can also find plastics and glass. These are the most widespread contamination inside the foods. Just to make an example, if a bottle broke, it's possible maybe to find in it some particle of glass that comes from the bottles and come inside the liquid. This is a kind of contamination, for example. But there are also other contamination that we can find in the food, for example, insects, stones or ceramic materials, and also animal contamination, unfortunately. Now, let's have a look on what kind of problems do contamination cause. For sure, one of the bad effects of contamination is correlated to safety problem, because if anyone eat this kind of bread with this kind of plastics inside, probably he will not feel well. So at the first place, obviously, there is a problem correlated to the safety of the human. But there are also other effects that are caused by contamination. For example, the cost for the recall of the contaminated batch. It's also probably difficult for a company to understand where the contaminated batch has arrived in the market. So it's also a problem to understand where are these kind of contaminated food. And for sure, there is also a cost for the disposal of the contaminated batches that, if you think, is correlated also to a sustainability problem. But we have not to forget also this other effect, that is a damage to the company reputation. If my favorite orange juice, in my favorite orange juice was found a contamination, and I read on the newspaper, on the online newspaper, maybe for 2 or 3 months later, I probably buy another orange juice. So there is also a problem correlated to medium-long time. Okay, now we try to answer this other question that is very, very important, and it's where do they come from? Where do contamination come from? It's very important to answer this question, because knowing where do they come from is also possible maybe to try a solution to avoid them. There are a lot of contamination sources, but for sure, at the first place, we can find a probable contamination that can come from handling systems. I think about a pick-and-place robot. I think about conveyor belt, gears of this conveyor belt that due to, for example, wear, friction, or other problems can, for example, break and create some particles that can come in contact with the food. For this reason, the handling system is one of the most important sources of contamination, can be one of the most important sources of contamination. As you can see from the picture, often to produce this kind of handling systems like conveyor belt, gears, and pick and place robot, we usually use metals or plastics. Another source of contamination is for sure product packaging. I made the example of the bottle, but it's also possible to find some plastic contamination inside the food that can come from a plastic packaging that is broken or made with some unsuitable plastic or glass, for example. But there is another source of contamination that can be correlated to operators' tools. I think about the pen that this operator is using. I think also of the glasses, for example, a cutter. Every tools that is used by an operator in the food industry can be a source of contamination. So, as you can see at the final slide, a lot of our materials are also used to produce some operators' tools. Okay, now let's have a look on the existing certification and standard that are live in this sector and are useful to optimize the food industry safety. Maybe you have already know this kind of standard that every European company is obliged to follow. It's called Hazard Analysis and Critical Control Points, HACCP. It's based on 7 rules that are common rules that are at the base of a lot of quality control system. And the rules are mainly based on 3 points. Check the critical control points where contamination can come from. Monitor these kind of critical points and establish corrective action. I would like just to make an example to clarify this topic. Let's imagine to work for a company that sell on the market some fruits, for example, apples. The apples are normally cut off the tree by metal tools. The metal tools can be source of contamination, as we already seen in the previous slide. So it's very, very important to monitor this point in order to avoid contamination. For example, just make an inspection of the foods with a metal detector, just to make an example. A possible corrective solution can be, for example, take the apple by the trees by hands and not by metal tools. It's a theory, just in theory, but it's the way in which this kind of standard think. But there are real certifications that are possible to obtain by food industries that are mainly in Europe, these two, BRC and IFS. These are the most used certifications in Europe. As you can see by the slide, on the left we have BRC, that it necessarily requires the use of a detector. So an inspection is required at the end of the production chain in order to check contamination and avoid them. In the second case, IFS, the most used in Europe, detector is not mandatory, but if it's possible to demonstrate that is not essential. But it's very difficult to demonstrate that is not essential because the company should demonstrate that is not using any metal or plastic tools. So the company can obtain this kind of certification thanks, for example, to audit, in order to demonstrate that all the rules proposed by this certification organization are respected. And it's very important to have a certification because some supermarket, for example, accept only supplier that has, for example, the IFS. I think about important supermarket like Conad, Tigros, Esselunga in Italy, want only suppliers, food supplier that has IFS. Okay, now let's have a look on the kind of detectors that can be used by the food industry, in the food industry. At the first place, we have obviously a visual inspection that is very, very important and is possible to make a visual inspection also thanks to operators, but often is taken by video cameras that can check if contamination of other objects with other colors, for example, are in the food. Then we have already talked about a metal detector. The functioning of a metal detector is a bit more complex. There is an electromagnetic field that is produced by a machine, an instrument, and if a metal contaminant is present inside the food, it can disrupt the generated electromagnetic field, and the detector relieve this kind of contamination. But there is also another instrument that is called X-ray inspection, another kind of inspection, very, very important, very expensive, that works in another way. The X-rays are electromagnetic waves that hit the contaminant, and the detector measures the emitted energy, the reflected energy, produced by the food and offshore by the contaminants. So it's possible to understand if a contaminant is present inside the food and what kind of contaminant is. The most important are these two, metal detector and X-rays. What are the difference between these two kind of detectors? Metal detectors can detect only metals, unfortunately, while X-rays can detect metals, glass, but also stones. The other difference, as I already talked about, is the price. A metal detector is a cheap way to make an inspection on the food, while X-rays is more expensive. As you can see, there is a material that cannot be inspected neither by metal detector nor X-rays, and it's plastic. Plastic that is used for a conveyor belt, plastic that is used for every handling system, packaging, operator tools that cannot be detected by any one of these inspectors tools. So it's a problem. So LATI has tried to propose a solution in order to make this plastic detectable. But before talking about detectable materials, let's have a look on the two most important inspection systems, starting from metal detector. As you can imagine, there are a lot of variables that affect the metal detector capability, detectability. Some of them are correlated to the instrument, for example, the size, the speed of the conveyor belt. The higher is the speed, the lower is the detection power. Some environmental factor that can disturb the signal, and also the intensity of the magnetic field that is possible to calibrate in order to check contamination or other stuff inside the food. But there are other 3 parameters that are correlated to the kind of contamination. In the next few slides, we'll talk about contamination material properties, contamination geometry, size, orientation, and shape, and also a food effect. Let's start from contamination material properties. I have already talked about the functioning of the metal detector. A magnetic field is created inside the cage. If there is a contamination, a metal contamination inside, it can create a disturbance of the magnetic field. Why? Because a metal contamination inside the magnetic field can create surface currents called eddy currents that are high if these 2 properties are high. We are talking about magnetic permeability, that is the capability of a material to be magnetized. And we are talking about electrical conductivity that everyone knows. Just to make an example, I would like to show you this table, just to make you understand that not all the metals are detectable in the same way. For example, ferromagnetic metals, iron or iron alloys that are used for handling system have good electrical conductivity and high magnetic permeability. For this reason, the detectability is excellent. While, for example, aluminum and copper that are not ferrous metals that have a low magnetic permeability but a very high electrical conductivity, the detectability is only good. While, for example, for steels, like normal stainless steels, both the magnetic permeability and the conductivity are low. For this reason, the detectability of stainless steel is only low. Okay, let's move to geometry factors of the contamination. As you can imagine, the bigger is the size of the contamination, the higher is the detectability. But there is other factors that are correlated, for example, to the orientation of the contamination. Let's imagine to have a contamination with a rod shape. If the rod is parallel, the axis of the rod is parallel to the magnetic field, it's very difficult to detect it inside the food. While if this kind of rod is perpendicular to the magnetic field, is less difficult to find it. So there is also an orientation variable. And there is also a variable that depends on the shape. More complex shape probably are more difficult to be detected inside the food thanks to a metal detector. I've talked about a food effect. I try to explain in a simple way. There are a lot of foods that, thanks to, for example, their electrical conductivity or permeability, disturb the signal, and for this reason, they disturb also the detectability of this kind of material. I'm thinking about fruits, for example. Fruits is mainly made of water. Water is an electrical conductor. For this reason, it alters the electrical conductivity of the area to be detected, and it disturbs the signal. But we can also think about salty foods, for example, chips or ketchup. The salt is an electrical conductor. For this reason, it changed the electrical conductivity of the environment inside the metal detector, and it disturbed the signal. There is another example, very common in the food industry, that is the iron contained in the blood, for example, for meats. The iron is a good conductor, but has an high magnetic permeability, so it affects also the signal of the metal detector. It's possible to try to find a solution in order to check only contamination and not the foods, trying to calibrate the intensity of the metal detector. So there are operators of a metal detector that can calibrate the instrument in order to check only contamination. Now I'm going to talk about the variables that affect the X-rays, the other main technology useful to find contamination. As in the case of metal detector, the most important variables correlated to the instrument are the detector size, the conveyor belt speed, same topic of metal detector, and also the X-rays intensity. While there are some variables, also in this case, that are affected by the contamination. I'm thinking about the size, the density, and a property that is called radiopacity. About the size, the same thing of metal detector. The higher is the size, the higher is the detectability of the contamination. The density is the concept at the base of the X-rays detectability. The higher is the density, the higher is the detectability. That's the reason why EV contamination, EV metals like iron, steel, but also glass, that are very heavy materials, are detectable thanks to X-rays. While, for example, light materials as air, insects, foods, and unfortunately our polymers are not detectable. There is also the case of some EV plastics like PVC or PTFE that can be detectable by this kind of instrument, but they are not used for handling system or, for example, packaging. So they don't often become contamination in the food industry. I've talked about radiopacity, and I try to explain you what it is. The radiopacity is a property correlated to the element, to the material, is the capability to shield, to absorb the X-rays, and not to transfer them outside. For example, the lead that was used as X-rays shielding in the X-rays human detection is one of the most important materials in terms of radiopacity. So every material has a different radiopacity. Okay, now we arrived at the heart of the presentation, and we'll see what does LATI propose to make plastic detectable. We start from an undetectable polymers. We add fillers that are mainly metallic or ceramic fillers, detectable fillers that make the material detectable. So the reason why we are talking about detectable compound. Detectable compound from a metal detector point of view, and we call them MDT, LATI materials. Detectable thanks to X-rays. In this case, in case of LATI materials, we're talking about LATIGRAY materials. That is the commercial name for X-rays detectable compounds for LATI. These materials have a lot of properties, and we'll see in the next few slides which kind of basic resin is possible to use to produce this kind of materials. We're talking about the detectability of this material that is very important in order to propose the right material for the right application. We are going to talk about food contact because mainly these materials are in contact with foods, so they have also to be suitable for a food contact. And we'll talk a bit about also the color. I think that you have already seen this slide before. It's the typical thermoplastic pyramid. And but just to make you understand that it's possible to use every kind of thermoplastic materials to produce detectable compounds, starting from polypropylene, ABS, polyamides, PBT, up to PEEK, PPS, or other high-performance materials. The aim is to propose the right material in terms of thermal, mechanical, and chemical properties, taking into account also the price for sure. Okay, now let's talk about the detectability of this kind of materials, because the concept at the base of the detectability in case of detectable compounds is this one. The higher is the detectable fillers percentage, the higher is the detectability. So somebody can propose the more detectable material, the high detectable materials with the higher percentage of detectable fillers. It's an option, but you have to take into account that increasing the percentage of the fillers, you can decrease or change other properties. I'm thinking about mechanical properties, for example. Let's have a look on how some properties change as we increase the percentage of the fillers inside. And we start with the density. The density is very important in some application because, for example, for tooth bins, it's very important to have light parts. But it's also important for a cost point of view, price point of view, because increasing the density, we also increase the liter price. Another mechanical properties that change increasing the percentage of detectable fillers is the stiffness, the Young modulus of the material, because normally these kind of fillers have a higher stiffness with respect to the base polymers. So increasing the percentage, we increase also the stiffness of the compound. While, for example, increasing the percentage of the fillers, we reduce the impact resistance. The material becomes more and more brittle by increasing the detectable additives. There are also other properties to take into account. For example, the dimensional stability. The kind of fillers inside this compound are normally isotropic from a dimensional point of view, from a geometry point of view. So we have a good material from a dimensional stability point of view. It's very important, this point. From a molding point of view, we have to make some modification to the tools, but normally we don't have any difficulty to mold these materials. For example, for high fill materials, maybe it's better to avoid hot runners, but in the most of cases, we can use them. It's also important to use our tools in order to prevent the wear by the compounds. It's also possible to change some mechanical properties of these kind of materials. For example, it's possible to add glass fiber in order to increase the stiffness or the strength, or maybe some impact modifiers in order to increase the toughness of the materials. Another property that is very, very important is also the antistatic properties that is possible to add to this kind of materials. And I'm thinking about tote beans, for example, tote beans for, I don't know, flavors. Due to electrostatic charge, the flavors can remain attached to the surface of this kind of tote beans. Thanks to antistatic materials, it's possible to favor, to help the detachment. So it's also a possibility that we can add to this kind of compounds. One of the most important questions from our customers is this one. Is your material suitable for our application, suitable to be detected by our metal detectors? Is a very important and difficult question to answer, but we try to answer in this way. Let's imagine to produce a tote beans in order to carry foods, for example, fish or pasta or I don't know, fruits. If these tote beans crash, it probably creates some particles that coming into contact with foods inside become contamination. Normally, the minimum size of these particles, of this contamination, we can reasonably think that is equal to the minimum thickness of the tote beans. In this case, 3 millimeters. There is a very well-known test in the metal detector sector that is called spheres test. What happens in this kind of test? Normally, the metal detector operators have iron spheres with a well-known detectability that they use to check the detectability of a metal detector in order to understand what is the minimum size of these spheres that can be detected. With our detectable compounds, we can proceed in the same way. For example, we can try to understand what is the intensity of a 3 millimeters plastical particles that correspond with the minimum size of our well-known iron spheres. For example, in this case, if you see at the left of the plot, we can see that the 3 millimeters particle dimension, this kind of contamination has the same detection intensity of iron spheres with an average size diameter of 1.5 millimeters. This is a technique where it's possible to understand if our plastic, the plastic used by our customer, is detectable or not. If it's not detectable, we can think, for example, to increase the thickness and so the detectability of the part, or maybe choose a more detectable materials. Okay, now let's talk a bit about food contact suitability. What does LATI can do? LATI can make a declaration where he declared that all the elements used in the compounds are in the positive list of the European or the American regulation. But it's very, very important to know that it's absolutely necessary to carry out a migration test of the real parts in the real end user simulation condition. And this is up to who puts on the markets the parts. So mainly our customers, so who puts the plastic parts in the market. He necessarily has to perform this kind of migration test. The color is very, very important. It's very, very important because if you remember, the first important detection system is the visual one. So if there is a contamination that has, for example, a brilliant color like a blue color, is easy to find it. Why we choose a blue color for our detectable materials? Because the blue is very hard to find a blue color for foods. I can think about blueberry, for example, but not more others. So it helps the visual inspection of a possible contamination inside the foods. That's the reason why we choose the blue. But we have also the possibility, for example, to create other grades with other colors. We have already produced red materials or yellow materials. So there is also this possibility. But we have also to take into account that it's a bit difficult to, for example, create a bright color because we start with very dark additives, and so maybe we can affect a bit the mechanical properties. Okay, I think that I've already we have finished to discuss about the main properties of this kind of material, so we can go on and talk a bit about the application, some successful applications that we developed for this kind of detectable materials. We can start from the conveyor belts. I already talked about conveyor belts that are used in the handling systems. What are the main requirements of the material suitable for conveyor belts? The first one is a good impact properties, but also a good dimensional stability, because we have to avoid any deformation for this kind of application. And also maybe a good resistance to scratch or abrasion. One suitable materials for this kind of application is, for example, TPU, polyurethane, that is very flexible, so very suitable for this kind of part. But in the case of rigid conveyor belts that move the one against the other with a conveyor belt made by different rigid parts, it's possible maybe to use polyoxymethylene, that is intrinsically self-lubricant materials, so it behaves very well in this kind of application. And it has also a good chemical property, chemical resistance, that is very, very important if the operators would like to clean the conveyor belts with, for example, thanks to aggressive chemicals. Tote bins, I've already spoken about them. The requirements are for sure not a high price, good chemical resistance in order to clean with aggressive chemicals like in the case before, and also good impact properties, because they should resist to, for example, crash or impact this kind of parts. The most used material in this kind of application is for sure the polypropylene. In the copolymer polypropylene, because it has a good impact properties also at low temperature. We have already developed a UV stabilized version of this kind of compounds because some customer asked to us the possibility to use them also outside. There is also another possibility, the ABS, another material suitable for this application, that had a higher abrasion resistance and also a higher dimensional stability with respect to the polypropylene. So it's a good second option. Operator tools, we found them in one of the first slides. As I already told you, a lot of our customers asked to us materials suitable for this kind of application, like a pen or a cutter. The main requirement is always the price. The price should be low for this kind of applications. We have suggested the polypropylene detectable version due to the high flexibility, the good chemical resistance, or for a more technical application, for example, a polyamide, which has, as you may know, a good and higher mechanical properties, but also thermal ones. I think that we have already found this kind of application, cable ties, for electrical sector. They are used also in the food industry, and they should be flexible. The material should be flexible, but also good from a mechanical point of view to maintain close the cable once is used. We have two different kind of material that we can suggest, that we have already suggested to our customers, that are polypropylene versions with good chemical resistance and also good mechanical properties at low temperature, but also polyamides that are used where this kind of cable ties are in an environment with a medium high temperature up to 100 degrees, for example. There are also other applications, for example, in this case, industrial ovens. Industrial ovens that can reach inside the temperature up to 300 degrees or 400 degrees. But in the most of cases, our materials are used outside these kind of ovens, for example, for handles. And in this case, the temperature can reach 150, 200 degrees. So it's very important, the thermal properties of the material, the chemical properties, because often this kind of foods of ovens are cleaned by aggressive chemicals. And the possibility are mainly these two, PPS, but also PEEK. We have some customers that use a PEEK for this kind of application. Obviously, there is a difference in price, but also a good difference in terms of thermal properties. We end the presentation with this kind of application that is not correlated to food industry, but maybe is correlated to electrical sector, home sector. And I'm thinking about old electrical systems that are not inspection, that are not possible to inspect. For example, some customer asked us the possibility to improve the detectability of old systems thanks to our kind of materials, our materials. The requirements are mainly these two: the price that should be as low as possible, but also an electrical insulation to avoid some problems of the electrical systems. I'm thinking about the junction box, for example, that are old but not inspectionable. We have already proposed material based on polypropylene, but also polyamide 6, with the difference that you may already know, the price, but also the thermal properties. So this is an untypical application for this kind of materials, not correlated with the food industry, but very important for us. Okay, now, if you want, we have the time for some questions. And okay, I have some question to answer, so I think that we can start. Is it possible to extrude these compounds into profiles and frames? Yes, there is the possibility to process these materials thanks to different technology with respect to injection molding. And some customers of our have already processed this kind of materials thanks to calendering, for example, or extrusion. And we have some customers also for 3D printing that extrude filaments for 3D printing in detectable materials. Is the mold affected in any way by the additive? I think that I've already spoken about this topic, but it's important to talk more about it. Yes, it's possible that inside these kind of materials there is the presence also of hard particles from an hardness point of view. So it's very important to choose the right tools, the right molds, materials, the right molds, metals, in order to avoid abrasion. So yes. Can you compound antimicro properties to your PP copolymer? Yes, there is the possibility to add some antimicrobial additives in it. They don't affect the mechanical properties, but also the detectability properties. So there is also this kind of possibility, yes. Can the materials withstand cleaning in place and or sterilize in place process? Yes, it's possible, but it depends on the base resin of the materials. We know that there are some base resin that are suitable for this kind of process. And this is, yes, a lot of properties of these materials are correlated with the base resin. So it's very, very important for anyone that would like to develop a new application in this kind of materials to come into contact with us, that we can provide a lot of information about the detectable materials, but also choose the right base resin in order to fulfill all the requirements. Are water and moisture affecting performance and safety of detectable materials? Also in this case, for example, in the case of polyamides, we know that the water and the moisture properties are weak, so there is a high absorption of water. So as in the case of glass fiber reinforced polyamides or virgin polyamides, obviously some mechanical properties can change during the absorption. So as in the case before, a lot of properties are correlated to the base resin. Okay, I think that we can finish here. And if other questions arrive in these moments or later, I can reply by email. And okay, I tell another time to join us in the next webinar. That is the 13th of July. And we will talk about a new sector, 3D printing, that is very, very important also for us. That's the reason why we are developing new materials suitable for this kind of application. So thanks for all, and have a nice day. Bye bye.